Now look at this heat line. Look at the angle it's on. It's not straight anymore. So that bubble point temperature or pressure is going to be different than the dew point. So that means that temperature, so if we go right across here, this is 40-degree line. This is the 40-degree temperature line and the bubble line. When we get all the way over here, it's almost 50 degrees. So there's like that 7 to 10-degree glide, and that's really what glide is. So if I was doing the bubble point, really, and I'm trying to measure it up here for superheat, and I'm starting over here, there's that much difference. And so that's where if you don't use that dew point, you're going to run potentially into some issues. You're definitely going to, with a high glide refrigerant, you're going to run into some issues. Welcome everyone to this 3-part session. I'm super excited about this. I love talking, love training. Today we're going to dive into scrolls. We're going to have conversation. If you have questions, please shoot them in the chat box. This is going to be going on to the Refrigeration Mentor podcast, so you can listen to it afterwards to take notes and stuff. And welcome everyone. I really appreciate all of you taking the time to do this. This means a lot to us because we like sharing our knowledge and we like helping you out there. And to be honest, I think we learn a lot more than you guys do when we do this stuff. So this is amazing. So my name is Trevor Matthews. I'm the founder of Refrigeration Mentor. I've been in the industry since 2004, 2005. Started in supermarket refrigeration and worked all my way up to owning my own business. Now I own a training business. I worked at Emerson or Copeland for 7 years. Did the training all around Canada for them. So a lot of compressor inspections. I'm saying hundreds and hundreds of inspections, fields inspections. And I did a lot of CO2 training with them. About 1.5 years ago, for those that don't know who I am, I started my own training, education, and mentoring business called Refrigeration Mentor to really share the knowledge I have. And I was that technician that didn't have a lot of confidence after 6-7 years in the industry. And that's what I'm trying to do now. Those techs that you've been in the industry, you know what you're doing, but you just, you need that validation sometimes. And this is what I'm trying to do, is get that confidence built in my company. I want to help build your confidence, share my knowledge so you can go out and learn more than me. I want you to understand what I can do and then excel, because then I'll learn from you. And that's what it's all about. And today we're diving into scrolls. We're going to be diving into everything scrolls. Questions you have, we'll try to answer them to our best. Tomorrow, we're going to be diving into semi-hermetics. That one's a little earlier. That's at, I believe, 10 a.m. Eastern. So if you're on the podcast, well, you probably can just wait till the next one comes out. And then on Thursday, we're going to be diving into compressor failures. So we only have an hour here. Maybe we'll go a little over an hour to see how Bob's feeling. But Bob, why don't you introduce yourself to everyone? Get everyone knowing who you are.
All right. Well, thank you, Trevor. I sure appreciate it. Welcome, everyone. My name is Bob Feathers. I started in this industry about 40 some years ago, I guess. My first go round was with the sheet metal union. I became a journeyman sheet metal mechanic. Got into air balancing, some residential service in a small town I lived in, and kind of worked the construction trade for about 12 years. And then I decided there was other avenues I wanted to pursue. So started working for myself, became licensed in the city of Dayton, Ohio. Eventually ended up with a state license in HVAC, hydraulics, and refrigeration. Still kept my ties with the union, still kept my ties in the business. And about 25 years ago, got into education. I used to teach at a very much 165 student tech school in Centerville, Ohio. And we had a pretty good program. Went from 65 to 165 by the time I left, and really, very good. And that's where I kind of started getting involved with the national groups, what used to be ARI back in the day. Eventually NATE, RSCS, PHCC, all the different national groups that are out there that do training and contractor stuff, and just really got into this trade. About 2005, I started working. I'd left the school and I started doing contract training for Copeland, and I did field test equipment on the first comfort alerts for them, and I worked as a vendor under them. In 2007, they made me an offer I couldn't refuse, so I came to work and worked considerable amount, mostly in North America. We did a lot of Western Canada, and Trevor was on the eastern side. We did a lot of the Western side. We'd spend 5, 6, 7 weeks out there a year and traveled all over talking about compressors and getting into various things, and just really had a blast doing it all. I had a chance to retire early, and I jumped on it. My wife and I moved to Southwest Florida. You guys may have heard of that recently after Mr. Ian passed through, but anyways, we survived and we're here and love staying involved in the industry. I still stay involved with the NATE Technical Committee and the local Southwest ACCA groups here, and do training on refrigerants and compressors, and still just stay involved generally overall. So thank you, Mr. Trevor.
Yeah, no, I love that. And yeah, me and Bob have done tons of trainings together. We've done cost courses together, done compressor courses. So we've learned a lot, especially what I loved about it for me was just getting my hands on the compressors and getting the experts to show us, and then we turn into the experts, right? From training and working with the contractors and learning. I think we learned I learned so much from doing those compressor trainings with technicians, because they would say, man, I seen this happen and this was going on. And then we look inside the compressor and wow, yeah, this is what it looks like. You know what I mean? Doing those steps. So anyone who has been to or hasn't been to a cost course yet, the what's it called again?
Compressor Operation Service Seminar. That's
yeah, awesome. You gotta hit that up. They're 3 days. I think they still do them for sure. They would still do them.
I'm sure they do.
Hit that stuff up. But once again, continue investing in yourself. So today we're going to dive into scroll compressors. And Bob worked and trained on scroll compressors a lot longer than I have. Why don't we talk just a little bit about the history that you know of Copeland compressors, because this is important. Because the evolution of scroll compressors, even in Copeland, is vast and it's big. And we talk about Copeland, but there's Danfoss, there's Bitzer, there's LG, there's Tecumseh Scroll. There's a lot of different scrolls, and you want to learn about those specific scrolls you're working on. But let's talk about a little bit of history we know on Copeland.
Sure, no worries. It's kind of funny being from the Dayton, Ohio area, Sydney, where the world headquarters for Copeland, and eventually after they bought by Emerson, stayed up in Sydney, Ohio. I worked for a large mechanical contractor up there. I did the startup and controls for this new scroll plant that was built in '88 and '89. And when I was in there doing the work, the facility was ready to roll. They just needed us in to get things going. And it was a very secretive group and bunch up there. They really were not letting the secrets out. They wanted to make sure you weren't there, spying and stuff. It was really kind of cool. But I've been involved with Copeland for a number of years as a service technician. Eventually got to know more people, especially when I started at the college. Got them involved with my school, and they just really do something that grows. But it's just funny with Copeland. Copeland originally was first founded in Michigan, and they moved to Sydney, Ohio, in the '30s. And started a facility there. And semi-hermetics was the main player in most applications. There was not welded compressors. And Copeland helped develop the CR compressor. And that was in the '60s and the '70s. And that really took them into the air conditioning side of things, or the comfort cooling, if you prefer that terminology. I know I like that better than air conditioning, but they were a refrigeration company, and that's what they were, Refrigeration Corporation Company. And they broadened in, developed the CR, got into the air conditioning market, and they just knew something needed to be done better with the old reciprocating style pistons going up and down, and loss, as you go back into your suction stroke and things. And so the scroll the ideas of the scroll been around for many, many years. But the engineers and the model shops up there, they started working on this in the mid '80s and such. And they started building these things and seeing what they could do with that, and seeing how they could make that a better compressor. And when, sometimes you think it's salesman talk when they say it's more volumetric efficient, or it's quieter, or whatever the terminology it's used sometimes. But in reality, it was better than buttons on a shirt. It really turned the world upside down a bit. And it didn't take long for other companies to realize that that's something that they have to do. And there's rotary technologies, whether they're true rotaries or scrolls. That's going to be the future. Pistons are still out there and they're still doing work, but these rotary technologies are really important. And, Copeland started these scrolls out. The first scrolls that came off the line up there didn't have a discharge check valve. Within about 3 weeks, they found out that was a mistake. And this was just something that wasn't thought about because you didn't worry about that with reciprocating applications. And they got that straight very quickly. They got a team of engineers that get into everything. And it's not just one or two people. They have lots of teams. They do all sorts of stuff. It's just
so that's a good point.
An amazing thing. Yeah.
That's a good point. So they didn't have discharge check valves. So what would happen, Bob, if one of those got stuck open, you got something jammed in them, one of them potentially failed? Because it could happen. They sell hundreds of millions of scrolls. So what could happen if you got an issue with your discharge check valve? And there's two different types.
Yes, correct. They have the disc type, and we used to have the ball type. Now it's a disc type. But yeah, if that happens, the discharge gas can rush back through the scroll set. And if potentially there's a call back for cooling again, a contactor's energized, it could physically run backwards, especially in a 3-phase application. And it created a lot of problems, and it made a god awful noise for shutdown. And they had this big noise as the gas rushed back through. And you got to remember, when the scroll shuts off, the scroll sets separate and they come apart. So it's an easy path from high to low through there. So if the discharge check fails, that's going to end up back toward your side, and it's going to sound like a train running down the track.
Yeah, so there's a tip right
simulate
there.
These in the labs, you know.
Yeah, and I've heard it too. So all of a sudden you have an issue with the scroll running backwards or shutting down, and as it shuts down, all that discharge gas is pushing back. It goes,
oh yeah,
making some good sound here, but it'll make it
to the sound labs. The sound
like
labs
that.
are a good place to learn them sounds. You know?
Yeah, great tip. So after they fixed that learning curve, because it's all learning, it was brand new, right? So they got that in there. What was going on with the design at that point?
Well, you know, it's basically meant to be a high temperature application for the comfort cooling things. As it went on, they developed more, and they went from version 1 to version 2 and into version 3. And something they really do is look at anytime they can make an improvement, you're going to end up with a different version number in that model number. And it is really, really pretty unique. And I'm not sure where they're at today, Trev. I think they were about 8 or 9 when I left.
Yeah. And that's so important. What you said there is understand the model number. It doesn't matter what compressor it is either. It doesn't matter the compressor manufacturer, that model number. Because when I was out in the field, I didn't always take down all the model numbers. I took down sometimes the first 4 or 5. Now take a picture, which is the smartest thing to do. Have those numbers there. But it's so important to have that full model number. Even those last 3, the bill of materials, are so important. And this goes for all manufacturers, because each one of those numbers and letters can mean internal, something internal in the compressor, the type of motor, even the type of feet that the compressor have on it. You know what I mean? So it's just so important that means a lot, because I've talked to a lot of guys, model number don't mean nothing. That's the wholesalers. They need to deal with that. No. As a technician, you should understand that stuff or know where to find that information out. And Copeland Mobile is a good spot to do that.
One of the first things we did in the compressor operations service seminar was to immediately go over model numbers and serial numbers and what that means. It is so important, because if you have an older compressor that fails, you're not going to end up with the same replacement compressor today. And that's even changed more as they've narrowed down the lines. And so there has to be some ciphering going on, some thinking. They gotta, and that's what the wholesaler does. He's good at that stuff. But yeah, that model number is really huge. And that bill of material is really important too. From the scroll perspective in the U.S. manufacturing, if that's the bill of material is the last 3 digits, and if that first digit starts with a 2, that's the original compressor that came in that OEM piece of equipment. If it starts with an 8, and in some cases a 9, then that has been a service replacement and was sold through the service replacement network. So when you see that 8 in that bill of material in the last part of that model, somebody else has been out there and changed that compressor prior to you being there. And now you can look at the serial number, see how old it is, and then you can say, boy, and now what happened and why am I back here now?
Exactly.
I think that's a good, knowing the difference between the 2 and the 8 is huge, Jeff.
That's a huge tip right there, because when you're in the field and you see that right off the bat, did this compressor fail? When did it fail? How many failures? It could have been, this could be the 3rd failure you're coming back to. So this is so important. And this is what good technicians understand. They can go and see, at least they know there's 2 compressors in there. At least there could have been up to 5. Who knows how many times, but a good technician will know, I know at least one, it failed once. let's go talk to the customer. Do they have any
Yes.
service or record reports that you can look at the whoever came in and said what the failure was? Because it's not a lot of, if the compressor failed, it's a system related issue 98% of the time. You know what I mean? It's not a compressor issue. It's something that happened while that system was running, or no maintenance, or there could be an endless amount of things not installed properly. But if you see that, you got to think, wow, this has been changed already. Like you said, go to that serial number. That's very important.
That really is. And just kind of getting a grasp on, and usually maybe you're out there on that failed compressor for the second or third time. They didn't call the original company back for a reason. You're back out there now. And so now you've got to get out that detective, book and ask the questions to the customer. I think that's always been huge. I've always been when I ran my company, it was a customer education, customer communication. Ask questions, see what's going on. And most good customers, especially in the air conditioning world, don't know a whole lot about the system, but they do know when they're comfortable and they're not.
Yeah.
And what happened or what led up to something that can be answered and found out very easily.
Yeah. And so when did the refrigeration scrolls come into play? So, because it started off as, like you said, comfort, cool, or air condition. When did you start seeing the refrigeration scrolls come in?
I'm going to say it had to have been, these refrigeration OEMs, as soon as they started seeing this and hearing this, they wanted to see how they could adapt this into equipment. So I would say at some point in the 90s, and I don't exactly want to say I know the exact date.
Yeah, don't
have sometime by the late 90s, they were probably developing refrigeration scrolls. I do know that they would. Some OEMs bought them high temperature scrolls and used them in a medium temperature application. They were never approved for a low temp at that point. But there were a handful of OEMs that did use those for medium temperature at 25 degree evaporator coil. And so, they had no choice but then, since they were a refrigeration company, that was their mainstay, was refrigeration applications, low and medium temp. They decided that let's get our crews on this, and that didn't take long. And they have to do some differences for those. We go through slides when we talking about the differences in costs between air conditioning and refrigeration scrolls. And without slides, kind of hard to get into deep, but they had to make that scroll more durable. You have to be able to work at a higher compression ratio. The floating seal in the thing had to be redesigned to not go up on a high compression ratio. And so a lot of things had to change. They had to change that dynamic discharge valve in that compressor. They went to vapor injection first, or liquid injection first, and then vapor injection. Then it didn't take long before they had that pretty well perfected. And add that oil control I see on your compressor behind you there, Trevor. They have to put sight glass in a compressor. You don't see a sight glass in many residential compressors, but commercial refrigeration OEMs want a sight glass. And so those things were very important for sure.
Yeah. And you got to remember, as a technician, because I've had this question so many times, it doesn't matter manufacturer, it's like, how come they don't put a sight glass on every compressor? Well, if your system is only $400 and that compressor, you go from a $50 compressor to a $100 compressor, it's the cost, right? So you're not going to have sight glass on everyone. And it's not, Copeland and all the manufacturers, they really build compressors for their customers. So a manufacturer is actually building the system, but I've seen it time and time again, the compressor manufacturer always gets the blame. Oh, the compressor manufacturer don't get a good compressor. But I've seen it a lot of times, installation, service, maintenance, manufacture of the equipment, wrong application. There's just the countless things that you can think of. Do they design compressors that have issues? Yes, it happens sometimes, manufacturers non-conformance or non-compliance. It happens because it's when you design a new piece of a compressor and you're designing millions of them, mistakes can happen. But with scrolls, for sure, it's all done by robotics. It's all done by so the amount of compressor issues you would see in a scroll compared to a semi-hermetic is totally different. Semi-hermetic, it's usually man-made, put together, remanufactured, and that's different than rebuilt, remanufactured. Why don't we go through about that a little bit? Oh, well, we'll talk about that in the semi-hermetic today. But it's important to know that scrolls is all built by robotics. So if there's an issue, it's a lot. There would be a lot of issues, and usually they get that done at the quality control. Why don't we talk a little bit about, because you've been on the scroll line many, many times. Why don't you talk a little bit about that?
Well, it's really kind of unique place. Like I say, automation is king there. Now you still have to have the human factor to load the parts into the machines, but there was three different manufacturers that were in together with the development of machining the scroll set itself. But a lot of the companies were from the Midwest, Cincinnati, Millicron, Dayton. There was a number of companies that got in on that thing, but the process on the assembly line is quite unique because it is 98% automated. Like I say, the only time the human hand's involved is if they're putting the component into the machine. Now, unless they load a wrong overload or discharge check valve or something, generally not going to be too much problem. One thing about the assembly line, let me give you a little example. Copeland doesn't, and you mentioned it briefly, Copeland doesn't build compressors and then sell them to OEMs. They have a salespeople, sales force works to sell them compressors. They work with an application engineer to make sure that compressor is going to be right for their system design. They're always visiting each other. They're always going back and forth. But there's one thing to kind of note for sure is that let's say Zero Zone wants 1,000 low temperature scroll compressors, 10 tons. Okay. They're going to build 1,010 of those compressors. And 10 of those compressors, every 100 that comes off the line, is going to go into the durability lab and into the test lab, and it's going to go over to the machine that determines whether it's got the right flow, and it does what it says it's going to do. The UL requirements for amp draw, and does the protector work. So they're constantly auditing anything during an assembly process. And I think that's very, very important to know, because if there's a problem, you talk about that 1 or 2%, that could be the factory issue. If there's a problem, they're typically going to catch that before we even get it out into a box and ship to a thing, because they know exactly where they're at. They know what serial number. It's all done in a numeric order, and they're pretty good at checking all this stuff. And it's the test labs there are really unique too, to go along with the assembly. But the assembly is really a special place, and they really have made just huge improvements in that. And they make them in Lebanon, Missouri now. They make them in Sydney, Ohio still. There are some plants overseas too. And one thing about the plants overseas, a lot of times they can't meet the need they need over there. So they don't necessarily always get built over there and shipped back here. I won't say there's not a couple exceptions to that statement, but generally it's they're made here, and they've just changed this, and automation is really where it's all at. And usually if there's a damaged scroll or something like it don't start on startup, it has more to do with shipping and handling, whether that's at the wholesaler, whether that's at our plant, the wholesaler, on the dock, back into the truck, up to the rooftop. A lot of times the handling of them can create some issues. And so if you got that one that won't start and won't go, it's not there. It could be that 1% chance, but very seldom is that truly the case. And that's kind of an important part. But it's really unique to see how they do that, and what their test labs. They have sound labs. They have durability labs. They just go on and on. And I mean, they just got hundreds of employees. They got employees that job nothing to do but break these compressors in the durability lab. Flood back, overheat, high compression ratio. You can kind of go on, and they just get the biggest kick out of it. And some of these machines, they've literally run the scroll almost out of oil before it fails. It literally is there's only just a few ounces left in there, because it's such a durable and such tight machining and such thing there. And let's mention machining real quick. And the difference in the scroll, Copeland scroll, compared to others, was the actual machining process. And the machining process is very unique, is that it was never patented. And the reason for it never being patented was, if you patent something, you have to tell them how you did it. And so it was really a big secret for them to keep that machining process very secretive group there. Not everybody could go in there. Thermo King was a guy I worked with, where it was the international salesperson for Thermo King, and they brought all the Thermo King executives up there to see Scroll plant, this operation. They wanted to see the machine room. The guy went and opened up the door and said, "Look, take a look," and then closed the door. So, and even though there was a large going to sell 100,000 compressors that year to them, that's how it was, and that's the way it was. But really, that machining process is so they get within just a micron or two in tolerances.
Yeah.
Usually machine processes is, thousandths or, a hundredth or something like that. But a micron, is very, very small, as we all know. So.
Yeah. And this is something that's important to understand, is that not all scrolls work the same. Like Bob said it there earlier, compression ratio is a big thing. The air conditioning ones or the comfort cooling ones have different pressure ratios or compression ratios than the refrigeration one. What is the compression ratio should be around for the comfort cooling compressors, Bob?
I think in most applications, whether it's even 22 or even 410A, there's not much difference there because your suction's higher with 410A. The 3 or 4 to 1's where you typically are running at. The durability works to about 7 to 1. And the floating seal, I think, doesn't fail, but it pushes up at, I think, 8 or 10 to 1. I don't remember the number off my thing.
Yeah, around 10 to 1.
Yeah, something like that. And but no, 3 or 4 to 1 would usually typical for air conditioning applications. That's why you don't want to take that air conditioning compressor and put it into that low temperature freezer, walk-in freezer you got, because it's just not going to be durable. The flanks of the scrolls themselves, are machined thicker for low temperature. So when I'm looking, and I do have a scroll set, when I'm looking at that scroll set there, and I look at the flanks are these edges through here, and the tips are through here. So when they machine a refrigeration scroll, these flanks are thicker. And so that as they go to compress at that higher compression ratio, they don't break. Now generally they're not going to have a problem unless there's liquid, but there can be liquid refrigerant and or oil, what they call a hydraulic slug. But there's just so many differences. But this thing is so finely machined, and such a big secret, still is today. Haven't changed the lick with any of that. It's really is pretty unique to see how they do that. So that's pretty unique process, Trevor. Great, thank you.
Yeah, and so that's a key thing to understand. When your compression ratio starts to get high, you're going to start to see what will you start to see, like your pressure start to change. You get a higher compression ratio. What does your amps do, Bob? Do your amps go down at that point?
I'd say they're probably going to have to work a little harder.
That's right.
Potentially.
So, you'll see your amps starting to go up. Yeah.
Yep. But the medium temperature applications at 25 degree evaporator, they might operate at 5 or 6 or 7 to 1, depending on the refrigerant sometimes. Low temp, 10 or 11 to 1 is not unusual for certain. And get into even some of them ultra low temperature applications, even greater than that. So, we generally don't get a bunch of that in most work that we do, unless you do work some pharmaceutical places and some of the places where they may want to get minus 50 or minus 60 or minus 70 degrees, which does happen in some places, but got to have a machine that will pump it for sure and be able to hold up,
Yeah, no, exactly. And then this is what you need to know. If you have your gauges on that scroll, on that system, and you're looking at it and you got a high compression ratio and all of a sudden they equal out, well, that could be that floating seal that Bob talked about. It lifts up. Right. So, and if that happens, it doesn't mean the scroll is failed. Yeah. You know what I mean? Do you want to just show that again, the floating seal?
Yeah, sure. Absolutely. Here's the front side. The discharge port would be up to the center. The side of it is, I always call this a vinyl sandwich. A piece of aluminum on the bottom, piece of hard cold rolled steel on the top, and then they were put together with a vinyl gasket. And what this does, it sits in a cavity on the fixed scroll. It sits in the cavity on the fixed scroll down here, like this. And then once the compressor starts to pump, it physically rises up and pushes against the bottom of the
You just want to hold it up a little higher?
Yes, correct. And it physically pushes up, and then that's what starts your compression. So if you get that high compression ratio, this thing falls and the compressor unloads itself.
Yeah.
And that happens a lot. So when a compressor isn't running either, it's unloaded. That is one thing about a scroll 2 compared to reciprocating. I got a 6-cylinder semi-hermetic compressor. Guess what? 3 of them cylinders are full of refrigerant. I got to overcome that every time I go to start. And with a scroll, you've equalized out between high and low side. The check valve kept the discharge gas downstreamed in the condenser, and it would equalize out. The system would equalize out through a metering device or something like that. But but physically the scroll is evened out when it goes to start again. It's equal pressure, and that really is probably one of the main things with the scroll. So yeah, maybe we'll get a chance to, when we talk about failures a little bit on the last day, we can go to, these are not failed components, obviously, but
Yeah.
I like these show and tell. Whenever I did classes for Copeland, I hauled around two cabbage cases full of parts.
Yeah. No, exactly. And the big thing is that when you're out there, if you get a failed compressor, it doesn't matter what compressor it is, you should keep some of them. You should be tearing these apart, looking. If they're out of warranty, you should be looking inside them. Now, if they're in warranty, depending on the manufacturer, depending on where it's at, you want to call your local wholesaler and distributor and ask them, can you cut these apart? What are you doing with them, right? Because maybe that wholesaler won't give you warranty for it, or that manufacturer of that equipment may not give you warranty. So you want to make sure you talk to the right people about if you have a failed compressor, because I've heard people getting denied of it because you cut it open. But all you have to do is make the phone call, and you have the compressor anyway. When you bring it into wholesaler and you're going to exchange it for another one, ask them, can I keep this to inspect it? And they're going to tell you yes or no. But over time, you're going to be able to collect some compressor. If it's out of warranty, you can use that, dump the oil and measure it, and then cut it open, and then we'll talk about that more on the last day. But it's important to understand when that compression ratio gets high, that floating seal can unbalance and it separates, and all of a sudden your gauges are equal. It's still running, but not pumping. And then what's going to happen at that point? It's going to keep running until what, Bob?
Well, until it goes off on motor overload. Eventually it's going to kick the motor overload off, and then it will cool off, and then eventually go to start again, and then go back to what appears to be normal. But the problem wasn't fixed with the high compression ratio, for whatever that might be, dirty condenser, whatever, 15 other reasons. But yeah, the motor overload plays a big part for the scroll compressor, especially in the residential air conditioning world. That is your protector. High compression ratio, high amps, everything in the world. If there's any, got a component that blows discharge gas on the overload, if there's a problem, you think you're off electrically, but it was something mechanical that caused that gas to blow onto the overload. And the overload is the UL protection device within those compressors, because a lot of those OEMs don't use a low pressure or a high pressure switch anymore. They use the scroll compressor can be its own protector the way it's built. And I know maybe you may have some slides on that kind of stuff, or you may, but it is really pretty unique on how they design that, and they can protect it and those things but from a mechanic standpoint, when that thing isn't running or not pumping, when it was a reciprocating compressor, what did we say? Bad valves, right, Trev? And guess what? There is no valves in these machines, at least not in the Copeland scroll. I know LG has a discharge valve, and maybe Bitzer, but anyways, it's and I grew up in a reciprocating world. When I first heard a scroll running in an application, it was in a rooftop piece of equipment. I thought to myself, what is wrong with this machine? Sound like a Wolverine with its foot caught in a trap. But I was used to that thumpity thump of a reciprocating compressor, and I didn't think that this won't work. That was my first thought, because I was young, and I don't want to say dumb, but that's you were set in your ways a little bit,
Yeah.
And that's kind of neat with that. But,
yeah,
the scrolls, they got a unique history. It's got a unique the way they do it, the way they build things, and they do that with all their compressors as far as that goes. But it's really pretty cool to see how they do that scroll assembly and build the extra ones for the testing, and make sure they're right and everything like that. It's pretty cool.
Yeah, it's a huge experience. I'm sure I know I went there before, and they took contractors in, technicians in. They do training there. If you ever have the opportunity to go to one of the plants, I highly recommend it. You know what I mean? Any compressor manufacturer, if you get the opportunity, you're in that city, reach out to them. A lot of them are real good, or if they're having a training at their factory, you should be scheduling, investing in yourself, just like you're doing today. Maybe you only can do it once a year or once every couple of years, but go to the Copeland plant, go to the Bister plant, go to Tecumseh plant, wherever it's at, and introduce yourself. This is how you build relationship, and then you'll learn about them. And this is how we learned. We dove in and really found out about them. And this is the big thing. Like, Copeland had over 25 scrolls when I worked at Emerson. They got more now. Bitzer has dozens. Danfoss has dozens. LG has dozens, I'm sure. Tecumseh, same thing. you need to get into the manuals. This is the big thing, is that we're talking about here air conditioning, medium temp, low temp. But if you're not getting into those manuals, and every compressor manufacturer has manuals. And one thing that I really liked about Copeland, they had specific manuals for that specific compressor. If you're not reading those, you're behind the 8 ball by far. You're just shooting wildly. It's a big thing that you need to do.
You know, it's really kind of funny talking about manuals, Trev. These were the old Copeland refrigeration manuals, the 101 through 105, that were the mainstay for the engineers to work with the OEMs on. And they were, everything was in a book and everything you had to look up. There was no online stuff. And so everyone got these books. And you might still find some of these around. I'm not sure if they I think they used to have their own publication department in Sydney. I'm not sure if they do anymore or not, but it was really pretty cool. But today, Trev, where can we find that information today?
Right here. So I'm going to show you. You got to go to.
Yeah. That's what makes the world great now today with the technology.
Yeah. There's go into, can you see my screen, Bob? Everybody.
Yes. Absolutely.
Go into climate.emerson.com and hit in OPI. So online product information on the first page. You go into publications and bulletins, and then for the U.S. publications, if you're in Europe, it's going to be different. But right here, AE manuals, what Bob was just holding up. This is the information here. This is what I learned on. This is what I went when I got my refrigeration ticket. I was learning out of these books, the ones that Bob just showed you. It's free online. Invest in yourself. Read them. It doesn't matter. I think I asked them to update this. You know what I mean? I would have tried to get involved in updating this stuff because it's, I think, the latest versions from the 70s or the 90s. I can't remember. It's old. They need to be updated. But refrigeration is refrigeration. It doesn't change. What do we got here? Oh, 18. So they did update it a bit. So the last time they did it, so which is good. Revision, the third revision of it.
Okay, they are updating them, Trevor. I did not know they did a recent update. That was
well, they still have it's not fully updated because look at the pictures, but the information doesn't change. Refrigeration, right? So it's important to do this. And then the other one is, we'll show you right quick. You go into AE bulletins, like we were talking about, application engineering bulletins. So here you go, compressors. If you go in air conditioning, look how many different manuals they have.
For each application, temperature, type of compressor, correct.
So many scrolls, and this is just the air conditioning scrolls. If we go back, you go into refrigeration, and then here you'll see a ton of different scroll compressors, right? You'll just find them. ZF, this is a low temp compressor. So it's so important to take the time to learn about that. Show again. So
can they access that through the Copeland mobile app today? They can get 100%. Into that also, can't they, Trev?
Yeah, I think for sure. And I actually did a good job updating. I remember when I was working with them, they were doing an update on a new technical section, and we'll go into that probably Thursday. But the technical section in Copeland Mobile, you'll have the resource section, I believe it is. And then in the resource, you got AE bulletin. So we're going to bring you to this OPI again. It's so important to read those. Those of you who take the time and start reading some of these manuals, you are going to be the next, great technician at your company. That's just the way it is. I've seen the technicians who's taking the time to read manuals, and it doesn't matter if it's what manufacturer it is. Those who are reading the manuals, learning about the exact how to install it, how to service it, how to maintenance it, those technicians are growing at a rapid pace. I see it. And that's how I grew. I've read hundreds of these manuals and read them over and over and over. And man, that's why I know what I know. And then field practice and the application. So we talked about it a little bit about comfort cooling, refrigeration, medium temp. What are you seeing now with the scroll compressors? So you said earlier 22-410. There's new refrigerants for scrolls.
Oh yeah. Well, I've kind of been trying to keep up a bit with OPI here in the last year and a half, especially since I've been doing the A2L refrigerant classes with the folks here in Florida, the contractors down here. And they're just now running. So they're finally getting the final approvals for R32 and 454. A couple of years ago, they weren't in there.
Yeah.
And I don't even know if 32 was in there at the beginning of last year. I could be wrong about that, but they're going to work very closely with those OEMs because they know what the OEMs need to have. And rather than, one thing I think I've seen in the industry since I've become involved in that nationally in the last 25 years, very simply, is that the industry now takes these problems before the government dictates to us what we have to do. And they look at everything. They look at how we're going to affect capacity in the compressor. They're going to affect the operation. When you go to a different refrigerant, guess what? You got a different capacity. It's a different density. And everything is a bit different. That's why you don't put these other refrigerants, drop-in refrigerants in. They might be easy and simple from a service perspective, but that they're not going to have the same capacity. They're not going to be the same. They're not going to, cool the product if you need, or keep you comfortable potentially, or maybe the draw will be different, and all these things that happen. This is why they work very closely with OEMs. They work very closely within their labs, and they have their own UL facility right in Sydney. I do know that. That's and they do burst tests. They check that motor protector, every part. Every part gets a complete overview and tested 10,000 times before it's approved to put in the assembly of a compressor. And that's done. That's pretty unique how they do some of that too.
Yeah, no, exactly. I just pulled up another slide here for the people that are listening, but you can see this AE4 1425 R5. That's revision 5. So that's 5 different changes they did on these specific model numbers. This is a ZF KAE, but now you have the YF, right? So now that's a different refrigerant. Z was always really it was 410 for the longest time, and then that was the comfort cooling. Then it changed into ZF for low temp, so a different refrigerant. But you see right down here, these are all the different refrigerants that this compressor can use. So the new refrigerants, 454A, 454C, 455, 448, 449. What's different about these refrigerants than R22, Bob?
Well, some mildly flammable is the term I think they like to use. Is that fair, Trevor? Is that what you mean?
Yeah. So, well, what I mean is that's one good point, depending on the refrigerant, but glide.
Oh yeah. They're blends. Sorry about that. Yeah,
because you're right. You're not wrong with
they're
that.
blends, and they have larger glides, and they never come a true fluid in the system like 22 or those other ones. They always became a true fluid, and so they evaporated all at the same time, condensed at the same time, changed state. They were easy. The oils that matched with them were compatible, and they could move the oil through the system. These blends working with glides, it gives you some advantages from a perspective, be able to absorb more heat in an evaporator or release more heat out of a condenser, but they'll give you a fit when you're trying to measure superheat or subcool it,
Yeah, and very, very important. So when you're checking superheat and you've got a high glide refrigerant, you need to be using that dew point. You got to be doing the dew point. I've heard lots of people say, oh, well, we should be using midpoint. I've heard this time and time again, but if you talk to the manufacturer of the equipment, you talk to the TX manufacturer, you talk to the compressor manufacturer, you got to use dew point for it. You got to be checking your evaporator superheat on dew point. Don't get that wrong. I know you're going to see more and more glide refrigerants, and the manufacturers of the equipment is battling this. I work with lots of them for years, and they're like, Trevor, I'm trying to design my evaporators, my condensers for a 10-degree TD, but the glide of the refrigerant 15 degrees. You know what I mean? So they're battling this stuff too. So it's definitely a learning process, and you need to understand. Like I've been diving in more and more on the engineering side. I keep saying this, that I'm learning more now as a technician. Learning about the engineering side, it's making me better as a technician. Like I understand the system, the flow, the components. And when you start to do that, it makes you as a troubleshooter so much better. So much better.
It's great to know the entire picture. The entire picture tells the story. It's like the neighbor that just assumes this or just assumes that, and you might think she's a bit of a busybody, or him. But in reality, you need to know all the story And we're all very much like that in life too. You see somebody do this or see that, but you don't know the whole story. And so the same thing with working in refrigeration and comfort cooling application. Understand the entire thing. The compressor is a main function. It's the most expensive component in most applications. I won't say that in maybe supermarket, but there's just so much to learn. And that the intent of the cost class originally, Trevor, if you never knew this history, was to train the wholesalers. When Copeland expanded their authorized wholesaler network, and of course there was no CRs and there was no scroll compressors back there. It's just authorized. Now they're called full line. I believe they still use that term because you got everything. But that they go into a town, there'd be they invite 5 wholesalers for dinner and drinks, and then pick one of them to be the authorized wholesaler for the for that city or that area or whatever it may be. It's broadened out from there. But originally it was developed to train wholesalers. It didn't take long to say, well, we can't just stop at wholesalers. We have to train technicians. And so, it really was pretty cool. The guy that helped develop that was a guy named Len Smith, and Len built the cost class, and he's the one originally that did the entire thing. In fact, I haven't seen the current slides they do now, but I think they probably still have some of those pictures in them. Yeah. If you know what I'm saying, be my guest from when Len developed that, back in the 70s. And then, and it was meant, and it didn't take long that educational services was born. Hey, we got to get out to every city in America. There's not a city in America I haven't been in. Yeah. Any major city, period. I travel 40 to 45 weeks a year, leave on Monday, come back on Friday. And if it's someplace I really like British Columbia, I'd stay till Saturday or something. But my wife called them mini vacations. But it's just so much to learn. And, if you can, I think they're still doing all those classes. Definitely check them out for certain. I know that there's a bunch of information, and, some of us old bucks are gone now, but that doesn't mean anything. The younger fellas like Trav and some of the other people that are in the industry today are taking a new grasp and a new approach to this stuff. We were pretty hardcore and kind of hard to change our mind sometimes on certain things, but you got to always be open-minded. I learned that many years ago from my mom. She was an English lady, so I had no choice.
Yeah. So we have a question. So someone asked, can you explain the dew point? So up on the slide for anyone who's just listening is the Danfoss Cool Selector 2 app. You should have Danfoss apps like for sure on your phone. This one here is the Cool Selector 2 on the computer. So I got refrigerant 448. Well, actually, let's start with R22. So this is R22. And if you look at this line right here, it goes straight across. You see how they go straight across? Because this is a single blend refrigerant. That means that there's not a mixture of multiple refrigerants. So they boil, just boils the same. So at the bubble point, which is this side, the liquid phase side, all the way to the dew point, which is the vapor phase size, that pressure and temperature is going to be the same across. But we go to 448 for an example, or 449, doesn't matter. Now look at this heat line. Look at the angle it's on. It's not straight anymore. So that bubble point temperature or pressure is going to be different than the dew point. So that means that temperature, so if we go right across here, this is 40-degree line. This is the 40-degree temperature line and the bubble line. When we get all the way over here, it's almost 50 degrees. So there's like that 7 to 10 degree glide, and that's really what glide is. So if I was doing the bubble point, really, and I'm trying to measure it up here for superheat, and I'm starting over here, there's that much difference. And so that's where if you don't use that dew point, you're going to run potentially into some issues. You're definitely going to, with a high glide refrigerant, you're going to run into some issues.
That's an excellent point. Boy, I haven't seen one of them in a while, Trav.
I use them every training. It doesn't matter what it is. I'm using those.
You absolutely should, for sure. That's I just being retired, you don't get into some of that. Hey, Trevor, just one thing I'm thinking about. I noticed there was a couple questions popping up, and I clicked on to one of them, and it gave me a list. Do you want to hang on a bit and catch them all together?
No, you go ahead. You hit one or two. You go ahead.
Well, that's
read it out first.
See. I'm going to assume that B, whoever B is, that was the first question.
Yep.
Can you tell? Okay. If the check valve at the outlet of the compressor is removed, what's the effect on the performance of the cycle? Actually, once the compressor is running, not going to have any effect on it. I wouldn't think.
Nope.
As far as, capacity flow, mass flow, any of that. It's just that when you shut it off, the gas will want to try to equalize back to the low side, and so it won't, no actual effect on a system that's actually running, but it'll be that noise and stuff like that. So, and then somebody said show again. I'm not sure what we were looking at there.
Yeah, that's okay. I think that was the get onto OPI. But going back to that check valve before we move on,
Okay.
is that there are some applications where even though you have the disk check valve, you may need to add an extra discharge check valve.
I forgot that.
Because a lot of people think, oh, well, got a discharge check valve. It's not a fully sealed valve. It's just a floating valve. So depending, if you're trying to pump down that system, you're probably, you got to check the type of compressor it is. You may need to add a discharge check valve. That's why those manuals are so important. Same with Tecumseh, same with LG, same with Bitzer, same with Danfoss, because I went through them. And then you could be having an issue and you're scratching your head and you're chasing your tail and you don't understand the compressor that you're working on. That's why it's very important to understand the specific compressor you're working on.
I grew up pumping systems down, opening them up, and doing whatever service you were doing to them. We won't go way back and talk about just purging, but the first time that I tried to pump a system down with a scroll many years ago, I'm running this thing. I'm holding this contactor in with my screwdriver. I'm pumping this thing down. The gauge gets to about 15, and it unloads itself. And I thought sure I just trashed a brand new compressor. And I ended up calling a buddy of mine I knew that worked at the labs at Copeland, and he said, "Listen, here's what happened." He said, "Don't try to pump that thing all the way down to there. Get out your recovery machine. You're not gonna pump that thing down like you would the old reciprocating application. Yeah.
Now this is what you got to think. So if you're doing residential air conditioning, or if you're working on any system, especially 410 system, because I know a lot of people work on 410 system, you're trying to pump that down. All of a sudden you're like, oh, 40 PSI or 25 PSI, just like you said, and all of a sudden it stops. Well, you probably unloaded that floating seal. So this is the things you need to understand. You didn't kill the compressor yet.
Yeah.
But if you have, just say you have a compressor with a failed low pressure control now, what could happen, Bob, if you have a failed low pressure control?
Well, and then it's not going to go through your pilot voltage to shut off. It's going to go off on the internal overload.
Yeah, and then it's going to run and run. And if you have a leak, what happens if you have no refrigerant and the low pressure control is not working?
Yeah, I'm sorry.
What happens if you have no refrigerant, so you had a leak and it just continues to run, and that low pressure control doesn't cut out the compressor?
Well, the floating seal should be able to catch that and notice that compression difference. But one thing about the compressor, all the Scroll compressors are refrigerant cooled. And so if I don't have refrigerant coming back to those machines at in not only the right quantities, but the right temperature and mass flow, that's what makes mass flow so important. If I don't have it coming back, I'm going to be kicking off on an overload because it's going to start getting hot. I can't cool that compressor motor, and the gas has to pass over the motor before it's taken up toward the scroll set to be compressed. Any liquid in it should fall to the bottom. In a perfect world, that doesn't startup's another story, but in run cycle, if I don't have the right mass flow, I'm going to overheat the compressor quickly, and we're going to see those signs of overheat. I love that picture you have of the scroll in your troubleshooting guide. I took that picture in the labs years ago, and that was the picture we added into the cost class years ago. I'm glad that you still use that, because that should never be, it shouldn't be those colors. That was an overheat, period. I mean, it like blew in a gun barrel almost, it shouldn't look like that.
Yeah. No, exactly.
I love that picture. That was great.
These are the things that you need to understand. Like there could be many things that you need to look at. So that system got no gas in it, but why didn't it shut down? Is it electrically fail? Did it trip on the overload so many times that the overload doesn't work anymore? These are the things you need to look at. And sometimes you have to open up those compressors. And I'm not saying if you're for residential, especially, you're not going to cut everyone open, but you want to look at least in one or two to understand what happened. So if you ever see that problem again, you know what to go for. Now, when we talk about more expensive scroll compressors, $5,000, $6,000 compressors, you want to really take a look at what happened to those.
Big
Right.
three-phase, yeah. And that relates to the question, and I think that's what we were relating to, what kind of damage from prolonged runtime with being in proper phase or wrong rotation. You're not going to pump any refrigerant, so you're not going to have anything coming back to cool the compressor. So
yeah, and
and
you'll even see in new guides, because they didn't have this before, that they'll run for hours. It could run up to an hour in reverse rotation with no side effects. But could there be effects? What are two things that aren't happening when you're running in reverse? You don't get oil,
yep,
and you don't get cooling.
Correct.
So you're causing damage, even though it's running back. It doesn't mean that the compressor won't start up, because I filled a lot of compressors up with liquid and started them up, Scrolls anyway, and they still ran. But were they as efficient as they were when they're brand new? No, definitely not. Definitely not. What else do we got here? So what is the reason for all Scrolls to be internally wired in Y? And are there Scrolls wired internally as Delta? I don't know the answer to that.
I don't. Have you worked with the electrical engineers there, the motor engineers, or dealt with any of them? I can answer that real simple, I believe. I don't believe they do any in Delta unless something's changed. Everything is a Y, so it can be center break. So it can be protected internally in a center break. So whether I've got that motor protector, that module that's in the thing on a semi-hermetic, or I've got, a scroll with its module, everything they want, they don't want this single phasing problem. If there's any issue, they want to be able to kill all three lines or all three power sources, not just one. And that's why they do that instead of the Delta. That's
a great tip. And then you'll see when you're ohming out the compressors, it's different for single phase than three phase. Just like Bob said there, you're cutting in the three phase, you're cutting all three legs. So you're like open winding, OL. So you need to understand how to use your meter. And you got to do this stuff safe. You got to lock out your power. You got to do all the safe stuff. Follow all safety procedure. We're dealing with high voltage. But three phase, open, OL. So that most likely in the three phase, your internal protector is open. But on a single phase now, all of a sudden you got, I got some resistance here, but I'm open here. Or I'm C to R, I'm open. C to S, I'm open. But S to R, I have resistance. What does that tell you, Bob?
That's a path. There's a path between there. They break them on the other side with those.
That's right. So now the compressor's not failed. Your single phase, your internal protector is open. And that could be from many things. What caused that overheat? And this is us as technicians. We need to figure this stuff out. We need to dive into it and find that what caused that. Not just put a new compressor in, pull one out, put a new compressor in. You need to figure that problem out. Or if you have to, because if it's a failed compressor and you got to put one in, do the investigation. What happened to it, right?
So if you got that, all three of your windings are open on that in a three-phase application. Check the temperature. Just put your hand on the compressor. If it's got any kind of heat left in it, potentially it's still off on the overload. I shouldn't give bad habits, but 35 years ago, we'd just give the thing a refrigerant bath, and it'd cool it off in a heartbeat. But you may have to go catch lunch today and, come back the next day or whatever it might be if you can potentially do that. But, you got to let that thing cool off first and then ohm out. Because if you don't, then you're going to end up condemning a potential compressor that hasn't been failed.
Yeah.
Okay.
That's
a great question. It really is.
Yeah, and it's super important to understand that stuff. Like, why did this happen? What do you need to do to take the steps to make sure that the next one doesn't do the same thing if it's a failure? Yes. If it's a cool off, you got to let it cool off, because there are compressors with internal components that will separate the scroll sets. And this is why you need to understand each different type of scroll and the manufacturer scroll, because an LG scroll is going to work different than a Copeland scroll, than even like a Bitzer scroll. Well, Bitzers have a lot of similarities, but they're different as well. And same with Danfoss. There's all these uniqueness. So the ones that have advanced temperature scroll protection, there's a big sticker on the side of it. And I've seen so many come back when I worked at Copeland that we put it on the bench, started it up, they ran perfectly. But someone cut it out because I got the gauge on, it's running, it's not pumping. And then it would trip off after a few minutes of running because it was running hot. But what's happening every time that you're not getting that cool gas coming back to cool that scroll down, you're building heat in that stator, in that rotor. So it could take a full day. They say, oh, up to 2 hours. I've seen 6 hours and it still didn't reset.
Well, in your straddle bearing, a big cast iron part that's up at the top above the rotor and the stator, if that transfers heat up there, that thing's not cooling off till midnight. Yeah. I mean, in reality, that's an excellent point for certain. Absolutely.
Another question. Will there be many changes we expect to see on scrolls with the new refrigerants? For sure. There's going to be lots of different changes. There's going to be changes in the system design, and there's going to be legislation depending on where you're at in the world, and we're kind of talking in gray areas here because it's going to be different in Europe, in North America. Canada has our own regulations, so it's going to be different. But the compressors are going to have to follow different rules, different glides. They're going to have the refrigerant's going to have different heat. They're going to have different capacities. And so this is what you need to understand. So yes, you're going to see different changes. Maybe the design of the compressor is going to be changed because they might have to add a different protector or add a different component inside the compressor. And I don't know all the details myself yet, but you're going to see some of these changes happen. And efficiency changes is a big one.
Yeah, Trevor, if you like, I could reach out to a couple friends in service engineering, maybe after the call today or something like that, and just see what they're hearing on this. My friend Tom Festmeyer used to run the labs. He went to train in lacrosse, so I don't have that contact per se anymore. But Brian Beinachek may also have a little information on that. Also, if you've ever had a chance to meet Brian, he might even. I can reach out to Brian. Let me do a little reaching out for everybody. And if you're on the call, the next call or the last call, we'll see if we can come up with a little better answer for that. You know what I'm saying? That's
well, the big thing is I can tell you how to figure it out right now is go look at the application engineering bulletin.
Well, that will get you there to an extent. Yeah, but I mean, they might be able to simply explain to me anyways. Without having to do all the work,
A2L, like I'll just show that screen because we're already at an hour here. But once again, I'll just show this one manual, and I haven't even read through this latest manual here. But you look, A2L servicing tools, Scott T 3-phase. Why don't you talk about that for a second, Scott T 3-phase? Bob, you remember what that is?
Open that up. Let me see the first paragraph of that. I think that's the thing on the front of it, right? That clicks on.
Yeah. So this here is when you're ohming out the compressor, and it's a 3-phase compressor. You're going to have one of them that it's a higher resistance than the other two, and you're like, oh man, must be something wrong with the compressor. The compressor's failed because I'm supposed to have 1 ohm, 1 ohm, 1 ohm as a 3-phase compressor, but I got a 1 ohm, 1 ohm, and a 2 ohm.
Yeah.
Just for an example, I'm just making those numbers up. But that is something that I didn't know about. And then because I'm moving on a compressor, I'm like, oh, this must be the reason why the compressor failed. But no, Scott T is a different type of winding. The way it's set up.
Those should be identified in the nomenclature, if I'm not wrong. The type of protector is in the electrical data on the model number. I think the Scott T. Now that I think back on that,
what page is this?
Should be
13. Let's go. To 13.
Should be identified in the nomenclature because it's the voltage, it's the phase, voltage, and motor protector.
Phase. So just giving you an example why it's so important to get into these documents of all the manufacturers. I'm reading more and more now of the other manufacturers. I even did at Copeland when I was working there. I was reading Bitzer ones, Danfoss ones, Tecumseh ones, just to get not as many Tecumseh scrolls because we're talking about scrolls, but they're hermetic compressors. But it's so important to dive into this stuff. This stuff.
I had to reach back in my memory stick on that one there for a second, Trev.
That's okay. That's okay because there's so much to know
when new stuff goes in.
Don't be. It's good that I don't know a lot of stuff. I'm reading these all the time, learning more and more every day. There's another question here. Will it still pull down running backwards? That's a great question. If you're running backwards, there's no compression happening. So you're not going to squish the gas. So you're not going to be able to pump down if it's running backwards. So great question.
Yes.
Great question.
Correct. I lost the questions. I'm not seeing them anymore.
Yeah, I think that was the last one in the question section. So what's your final thoughts on scrolls, Bob, before we let everyone go here?
They're a fantastic machine. Their volumetric efficiency is so efficient that can create some issues in some cases for the service technician. They're not used to pulling down like that, or being able to get right on and start pumping. It's just one of these machines that, and like we would do in the cost class, you really need to learn how those compressors work. And we had a one-day scroll class back in the day too. I don't know if any of that's
I think
still
they still do
active
it.
on
I
their
did a bunch of
educational services website. But you got to learn how they work, all the parts, what's going on in it. I will tell you that there's a whole lot less moving parts in a scroll compressor compared to reciprocating. And we used to argue internally, Steve and myself, on how many there was. I counted 7, he counted 9, but here or there, better than the 26 that were on the other one. But it's just one of these things. It's a bit of a mystery machine. Anything that's welded shut is a mystery machine. And so understanding it, when you do end up with that failed one, and you can cut it open and fight. You can just grind that weld right off the top cap, smack it with a ball peen hammer. It'll probably break. You can pull it off, start unbolting the scroll. Check that oil. Anytime you can check your oil, it'll tell you there's guides out there on what different oils look like and stuff. And that's one of the first things they do when they get a compressor back for a teardown. Is drain it. Well, first they put it on the dry air board, see if it'll start and pump. From that, they'll drain the oil, and there's just a ton of information there. I do know that contamination from CFC and HCFC refrigerants went from less than 1% up to about 6% at one point. I don't know if that's gotten better, with the use of HFCs and POE and tags and stuff now. But, it's a mystery machine. So try to learn as much about these things as you can. I know Danfoss has great audios and cartoon things with the run. And Copeland was developing them at one time when Larry was around. I don't know if that still ended up where you had those visuals in a cartoon like thing, and they were pretty cool, and everybody's doing that now with refrigeration cycle and all kinds of stuff. But it's just so much to learn about a scroll compressor, and each one is different, like Trevor mentioned earlier.
Yeah, 100%. There's different scrolls, there's different flanks. Some have Teflon seals, and there's so much you need to understand each specific scroll you're working on. We're going to be doing this again. We're going to be doing semi-hermetics our next session. Bob, how can people get a hold of you if they want to learn more about you, your company, your training that you do?
Sure. No worries. That's I have a company called HVAC Specialties. This is a retake off of an old company I did when I did accreditation visits for tech schools around the country with Para. And I started the union halls and worked with the Department of Ohio Education, developing curriculum, things like that. So I had a separate thing from my contracting company back in the day. But it's a train. What I do today is I'm training on compressors, these new refrigerants. I'm going to be expanding into. I've been working with HVACR.edu on supermarket stuff, kind of a very basic compared to what Trev does with some of his stuff. But to get that air conditioning guy involved. But you can get a hold of me at Bob HVAC1 at me.com. So Bob HVAC1 at me.com. And Bob is a capital B. Everything else small letters. And it's one of those Apple IDs. So Bob HVAC1 at me.com.
Awesome, Bob. Thank you so much.
Remind me where we talked at if you send that to me. If you send me any questions or anything, I'll be glad to help you. Sure. I'm retired, but I love to talk and love to help folks. I've been doing it for a long time.
Yeah, no. So get Bob. He'll come and do in-person training if you need on compressors. He's an expert. He knows Copeland's better than I do. So, it's important to learn, invest in yourself, get into these manuals. Share the information as well. This is the biggest thing. If I can tell you anything, investing in your knowledge is number one. More important than your job is investing in you and your knowledge. But the biggest thing after that is sharing that knowledge. That's where you learn more. I learned so much from doing this talk. Right now, I'm already thinking about 5 or 6 things that I want to add to the next time I have a talk. And just from the great questions that you guys all put on there. So once again, we're going to be doing another session tomorrow. Same link. If you have the link on here, if you're listening to on the podcast, I'll be putting it out again soon. I want to thank everyone so much, and we'll catch you tomorrow at the semi-hermetic session. Thank you, everyone.
All right, keep plugging out there, guys.